All right, let's talk about physics with calculus. All right, yay. All right, so it all started with Pythagoras in the 6th century. You know him from the Pythagorean theorem. All right, so he started inventing some of the math that we use today. Discovered. I don't know. It's one of those interesting things. All right, so then it moved on to Galileo. All right, so he started dealing with some ideas. He really started studying kinematics, which is basically motion, and he realized it didn't explain complicated motion, but it was easy for simple stuff. All right, so 25 years later, we get Isaac Newton and, oh, I don't think I can say Gottfried Leibniz. I probably said that totally wrong, but that's okay. They're the ones who came up with calculus, all right? So Newton began his work first, and then Leibniz, I don't know, however you say that, he published his findings, okay? So that's where we get calculus. I shared a video on there with you from Neil deGrasse Tyson talking about this. Not to make you feel bad or anything, but Isaac Newton invented calculus in his early 20s to explain planetary motion. All right, so what is calculus? Some of you already know, you've been in calculus already. Some of you are just starting calculus this year. What it allows us to do in physics is solve more complicated questions. So regular math, we get a solid, smooth, straight surface. For calculus, we start to see things that are curving, okay, things that are changing, so more sophisticated problems. All right, so the question asks about energy for a straight incline. It's just not very hard, okay? You can use regular math, regular kinematics with some forces, or you could straight up use some energy equations. We're not going to solve that right now, okay? For a curving incline, though, things are constantly changing. So curves indicate constant changes, okay? The steepness of the incline is changing. So some parts of it are going to be easier to push the crate over than others. So we need a way to do these more complicated problems where things are changing, okay? So calculus is a mathematical way to express something that is changing, okay? It could be anything, but here's the cool part. This is a calculus problem because it's curved. What calculus allows us to do is zoom in on a really, really small part and then use regular math tools to solve that. All right, so regular math versus calculus, okay? Regular math, straight lines, this is easy. This is a Pythagorean theorem, a squared plus b squared equals c squared. Calculus, how long is the cable? That's a little more complicated because this isn't straight across here, and you got to use some more sophisticated math, okay? Again, regular math problem. What's the area of this roof? Well, that's really easy. They are squares or rectangles. That's easy to find an area of that. Now a dome. How do we find the area of that? That gets a little more complicated. That's your regular math versus calculus. So last year's physics problems that you worked on were over here. This year, we're going over here. All right. So here's another example. This is football, pass. This is the math we would use before. We'd use some trig and some algebra. Now we can do a problem like this. You see some planets here. We have a shuttle here. If you want that shuttle to run into Mars, you got to use some calculus. You don't want to miss this one. This one, if you miss it, it's not a big deal. Your team might not score. This one, you've just wasted a whole lot of money, okay? All right, so calculus is all about rates of change. A rate is anything divided by time. Change is expressed by using the Greek letter delta. We used it a lot last year, so that should not be new. Here's an example for average speed. It's simply the rate at which the distance is changing. So you get the change of distance divided by the change of time. All right, so derivatives, I've already mentioned this. It's just the slope, okay? So since we are dealing with quantities that are changing, it may be useful to find what that change actually presents. All right, so this is the end of part 1 of my video, Why Calculus? We will do part 2 in just a moment. I figure out how to stop this.